All right, we're going to graph absolute value inequalities. It's very similar to how we graphed equations yesterday. There's just two extra pieces on top of it that we have to look at. Now, before I get to the examples, if you look at the part that talks about a solution set, a solution set is all of the answers that, or all of the x and y values, or all of the points that make your inequality true. So when we're talking about greater than or less than, there's usually a lot of options that might make it true. Now, it also graphically is where it falls in the shaded area or on a solid line. We'll look at that when we look at graphs, but let's go ahead and take a look. All right, so two things with inequalities is shading and line type. Those are the two little extra pieces that are different than equations. Okay, so remember we have less than or equal to, greater than, or greater than or equal to. Remember, an easy way is less than. If you turn your hand as an L, it makes kind of an L. If you're making a less than sign and you turn it upright, it looks like an L. Okay? Now, so for shading, if it's greater than sign, we're going to shade above. If it's a less than sign, we're going to shade below. For the line type, okay, so we had shading and line type. A line type, if it has just a less than or greater than, it's a dotted line. If it's a less than or equal to or greater than or equal to, it's a solid line. One way that I remember it is if it has a line underneath, it's a solid line. Or if it's equal to it, it's a solid line. Now let's take a look at this example. Okay, it's very similar. So I'm going to set it up the same. I'm going to have my x and my y. Okay. But before I do that, I'm going to talk about real quick, write down like what shifts I might have, and write down what type of line I'm going to have. Well, this -2, remember that's going to be your right 2. Okay, remember it's the opposite. And then this sign right here, that's a less than sign, doesn't have a thing underneath, so I'm going to do a dotted line, and I'm going to go ahead and put dotted so I don't forget. Okay, sometimes writing that down there lets you remember when you actually do the graph. Okay, so when I make this table, I have -2, -1, 0, 1, 2, and then this becomes just 2, 1, 0, 1, 2. That's the same thing that we did yesterday. Okay, so now I'm going to go ahead and plot those points. Make that V, but I have to shift all those points to the right too. You can draw on your V or just shift our points to the right too, which I'm going to do, just shift it to the right too. And now I have to draw a dotted line, so I'm going to draw a dotted line when I am making this V. Okay. Draw my arrows, telling me that it's going to go on forever. Okay. Now, before I call myself good with this, we have to have a line type and shading are the new parts on here. So it's a less than. So when I think less than, I think below. So I'm going to just kind of take my vertex right there and draw an arrow below. Well, that's where I'm going to shade, is below this. So anywhere below this line, I'm going to shade. Okay, notice this line really goes on forever, so I still stay below this line. Okay, that is our absolute value graph. Okay, it's okay that I shaded over my original graph. That was just my parent function to help me graph. Let's take a look at another one. Okay, so for this one, I'm going to go ahead and look and just write what I know. Well, this -5 is going to be down 5. So I put D5 for down 5. Plus 3 is going to go to the left 3. Okay, that 2 is just going to be what I multiply my y by. And this tells me that it's going to be a solid line, since it's an equal to. Okay, so let's make my xy table. Okay, so -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. Remember, that's just the absolute value of all those numbers. Okay, but there is a value right here, an a value that I'm going to need to multiply by. So I'm going to multiply all of those by that 2 value, by this guy right here. So I'm going to times all these by 2. So 4, 2, 0, 2, 4. And I don't need this anymore. So let's go ahead and graph these points. So -2, 4. Okay, -1, 2. 0, 0. Boom, boom. And if you want to draw that in, you can, or you can just keep your points. And we're going to go ahead and shift all of my points to the left 3, down 5. I did the middle one first, then I'm going to do the left points, and then I'm going to do the right points. And then we know it's a solid line, so I'm going to draw my solid line in there. Okay, try to make your line straight. Mine's a little off because I'm using the iPad. Okay, so now I have my solid line. Now the last thing we need to do is shade. Okay, see how it's a greater than sign? So I'm going to shade above. So greater than is above. So if you notice, above is going to be inside here. So I'm going to shade inside of this V. Notice I don't go outside of it because it's going to keep going on forever. So that's what my shading is going to look like. Okay. Now, when we have this shading, that means that any of our solution set or any of our points that are inside of this shaded area, okay, is going to make this inequality true. All right. Graphing an absolute value inequality. Here's this last one. So I'm going to go ahead and same thing. This plus 2 means down 2. Okay, make my table. And I'm going to go ahead and put dotted since it's just a greater than sign. Okay, so I'm going to go ahead and do -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. There's an a value of -1, so I'm going to multiply all of these by -1. So that just makes all of these negative. Remember, that's just going to reflect our graph. Okay, so don't need that one anymore. So I'm going to go ahead and graph these. So -2, -2, -1, -1, 0, 0. That's a little off. 1, 1, and 2, -2. Okay. Now I'm going to go ahead and shift everything up 2. So I'm going to change my color. I'm going to go blue and shift everything up 2. Okay, and it's a dotted line, so I'm going to go ahead and make a dotted line. All right, what's the significance of shading with absolute value inequalities? The significance why we shade is because it tells us our solution sets. So the shaded area is our solution set. So that means it's all of the points that would actually make that inequality true. Okay. Why do we make a distinction between solid and dotted lines? Because solid lines include the points in our solution set, where the dotted line do not include those points. All right, go ahead and take a look at your practice problems and give them a shot.